Good afternoon, online. Good afternoon. You all here in there? So, when I start differentiation, but I'm going to do a quick review on differentiation. I'm not sure if I already remember anything. Right, but I want to just run through quickly some differentiation, and then we will start in new stuff. It's a nice short topic, to be honest. It is short. This is probably one of the easier things in this unit. Right, differentiation. Right, the only new things in differentiation that you will do is something called implicit differentiation that allows you to differentiate y, and then partial differentiation, where you have more than one variable, but you only differentiate with respect to one. Right, nothing else really new. You have to differentiate e and ln, and that's it. Right, elon. And that is it for differentiation. Right, the tricky ones are like inverse or sine and cosine. All right, let's do a quick review on differentiation, right? Quick review. What's the differential of ax to the power of n? Right, the differential of ax to the power of n, you bring down the n, you write back the a, and you minus 1 from the power. Right, the differential of ax is simply a. The differential of a is simply 0. Right, we should also remember that the second differential, right, which is d2y dx squared, is equal to the differential of dy dx. So it's like you differentiate twice. Right, we need to remember how you differentiate this again. Ax plus b to the power of n. How do you differentiate that? The two methods, right? The shortcut method and the chain rule, right? So the shortcut method is bring down the power, differentiate inside the bracket, put back the bracket, and minus 1 from the power. Okay, that's the shortcut. Or we could also say that dy dx is equal to dy du by du dx. Okay, that's chain rule. And then you have two more rules. You have your product rule. And you have a quotient rule. Right, see if you remember the rules, write it down. Right? Product rule is what? Product rule is u by dv dx plus v by du dx. Quotient rule is v minus, sorry. Quotient rule is v du dx minus u dv dx all over phi squared. Okay, that's just some of the rules that I need to remember from unit 1, right? Oh, I should squeeze in cos and sine and thing. I squeeze it in right here, right? The differential of cos is minus sine. The differential of sine is cos. Anybody remember the differential of tan? Nice. The differential of tan is sec squared. Okay, so those are the rules that we need to remember from unit 1 and from 5. Finish? Okay. So now we're going to learn about the differential of. We're going to learn about, firstly, we do the first one, the differential of e to the f of x. Right? Here's what you're doing. To differentiate y is equal to e to the f of x. Real simple. All we're going to do is differentiate f of x and then write back e f of x. That's it. So if I gave you y is equal to e to the 2x, what's the differential of 2x? 2. And then you write back e to the 2x. That's it. That's how you differentiate e. Differentiate the power and put it in front. And that's it. Hey, you know, I could have given it by first principles and make it prove it. I remember that. First principles. Are you okay with that? Try number 2 and 3 here, please. Finish. So you'll get dy dx is equal to 1 e to the x, right? Here, you'll get the differential of 2x minus 1 is 2. Write back the 3 e to the 2x minus 1. So you'll get 6 e to the 2x minus 1. That's okay? Easy, right? Okay there? Nice. Let's do learn one time. Let's do learn one time so I can put them together after. Differential of ln f of x. Right? Nice and easy. The differential of ln f of x is simply f of x in the denominator, and the numerator is the differential of f of x. So if I ask you to differentiate, ln 2x minus 1, real easy. All you're going to do is you're going to put 2x minus 1 in the denominator, and the numerator is the differential of that. That's okay? No more learning it, right? No more learning it. Huh? Ln can be negative. That's why I keep putting modulus in front. Oh, yep. Try those two there. Okay. Right? Whenever you're doing questions with ln, you have to remember your ln rules too. Power rule and division and multiplication, those rules. Sometimes you just need that to simplify it. Oh, yep. Last minute. Hello. All right, let's see what you got. So we have dy dx. The denominator is 2x minus 4, numerator is 2. If you want to simplify it, you'll get 1 over x minus 2. Divide everything by 2. Okay, that's an option, but you don't have to. The next one now, before you start to differentiate, break it up. Take the 5 and put the 5 in front. So that'll be 5 ln 2x minus 4. And now you could put 2x minus 4 underneath, leave the 5 on the outside, differentiate 2x, differentiate 2x minus 4 and get 2. So your final answer will be 10 over 2x minus 4. Everybody okay with that? Yeah, nice. Online, any issues online? Everybody okay there online? Yeah, are you okay? All right, let's go a little more complicated. How you will handle number 4. Y is equal to ln 2x plus 1 over x minus 3. How you will differentiate that? No. Got you? Right, so we can kind of split it. So we will get ln 2x plus 1. The divide means what? What? Divide means subtraction, right? So you'll get ln 2x plus 1 minus ln x minus 3. William, that was you? Who said multiply? And then you differentiate like normal. So you should have 2 over, and here you should have 1 over. If you want, you can find the LCM and break it down. You could use quotient rule. Well, yeah, but check the problem out, right? If you use quotient rule, then your denominator is 2x minus 1 over x minus 3. And your numerator is where you have to go and differentiate all of that. So yes, you can do it, but you'll see how much work is up. You see how much work? But yes, you can do that. But it's a lot of work because you have to differentiate this entire denominator and then work it out. Right? Try number 5. Ln tan 2x. Right? So your denominator here is tan 2x. What's the differential of tan sec squared? What's the differential of 2x 2? So it will be 2 sec squared 2x. Right? Remember to differentiate tan, you differentiate tan first, and you differentiate 2x, and then write back 2x. Look at it. There's something I want to note, right? I don't think I showed this in the beginning. Suppose I ask you to differentiate e to the x, right? We know the answer, right? We know the answer is e to the x. That's okay? But there's a way for us to do that as well. So if I told you that y is equal to e to the x, there's a way for us to actually show that. If I were to take ln on both sides, I'll get that, right? Yeah. So if I have ln y, I'll end up with ln y. The x will come in front, ln e. What's ln e again? Ln e is what? 1. Ln of e is 1. Okay? So you'll be left with ln y is equal to x. If I ask you now to differentiate ln y is equal to x, what you'll get? You'll get y in the denominator. Well, what's the differential of y? dy dx, right? Nice. And what's the differential of x? 1. You've seen that? So the differential of ln y is dy dx over y, and the differential of x is 1. And watch this here. You will end up with dy dx being equal to 1 multiplied by y. But y is really what? Remember? Y was e to the x. So we could differentiate y as e to the x by taking ln, and you'll get the same thing here. See that? So that's how they got the answer. All right, copy it down. All right, try this one here. So try for me, forgot what number we reach, right? Let's pretend it's number 5. Try to differentiate y is equal. I'm changing it from e, and I want you to try 3. Try to differentiate y is 3 to the power of x. Can't follow the steps. I'll show you this now. You don't have to work out ln 3, right? You would have ln 3. Same principle, right? Take ln on both sides. Take ln on both sides and then try to differentiate. Right? So y is e to the 3 to the x. Try and take ln on both sides and then apply it. Right? You can leave your ln 3 in your answer. You don't have to work it out. All right, let's see how it went. So the first thing I will do here is take ln on both sides, right? So I'll get ln y is equal to 3 to the ln 3 to the x. So ln y is equal to x ln 3. Ln 3 is a constant, so I'll leave it right there. And now I'm going to try to differentiate. The differential of ln y is dy dx over y. And here you'll get the differential of x is just ln 3. Right? The differential of ln x, sorry, x ln 3 is just ln 3. Because remember, this is a constant, right? If you want to work it out, feel free to work it out, right? But dy dx is equal to ln 3 multiplied by y. Right? And we know what y is. Y is 3 to the x. So you can write your final answer like this. 3 to the x by ln 3. One more like this. Suppose I gave you y is equal to e to the 2x plus 1. Do it the long way. You should know what the answer should look like, right? But do it the long way from what you get. Y is e to the 2x plus 1. Right? Let's see what you got. Again, the long way. You don't have to do the long way in this in exam, but I want to just make sure you get the hang of the long way, right? So you're taking ln, right? So you'll get ln y is equal to ln e 2x plus 1. This is ln y is 2x plus 1 because ln e is 1. When we differentiate, we'll get dy dx over y is equal to 2. So we'll get dy dx of 2y, which is 2 by e to the 2x plus 1. Nice. Now for one that came in a past paper once, 17 or 18 or something. Ready? Try this here from me. Try and see if we can differentiate y is equal to x to the power of x. X to the power of x here, William. I'm gonna see what you get. It's not tricky. Take your time. Same thing, take long. Let's just see what you get. Right? Right, so online x ln x is a product. There's two functions in x, right? Yeah. Good job, do you do it? Wrong, very good. Very good, wrong. Follow it wrong. Yeah, look at it. Right, so remember x ln x is a product. Right? X ln x is a product. Right, so online, remember when you're working it out, remember that x ln x is a product. So be careful when you differentiate in that. Any answers as yet? Right, so I want you to picture this as a product, right? U is x and v is ln x. du is 1, dv is 1 on x. Right, I'm giving you 2 minutes. I have one answer so far. I have one answer so far. All right, let me see everybody. All right, Andy, doing your work there? Hey, Andy didn't come to no class about you. He didn't come Saturday and Friday. No, Saturday was. Oh, he was there? Okay. Right, take your time, simplify it out. Y is equal to ln y is equal to dy dx over y. X ln x is what? X by 1 on x plus ln x by 1. When you multiply it out, you'll get dy dx is equal to y by 1 plus ln x. Okay, let's remember the x and x will cancel, right? The x and x will cancel, and you'll get 1 plus ln x. Product rule, remember product rule, u by dv plus v by tu. Yeah, I feel I'll forget product rule. Have a thing called product rule. Check back the formula and just substitute it back. And you'll be left with dy dx is equal to x on x. Right, Nathaniel, is so what's you left out? I'm gonna pick up what you have. Right? I suspect you probably didn't use product rule properly. So I use product rule here to differentiate this. This was u and this was v. And when I differentiate, I forgot that. But you okay there? So that came in a past paper once. I wanted to show you that, right? Good. One last one on this logs. What you will do if I give it in logs? Remember, I only taught you how to use log, right? What you will do if you have this, if you have y is equal to log to the base 2, yeah, 2 good. Let's put to the base 2. How you will differentiate something like that? Remember, I only taught you log, right? I didn't teach you anything with log. What you can do there? Anybody online or here? Change the base, yes. Change the base. Change from log to the base 2 to log to the base e. That's one option. Next thing we could do is this. Watch this here. We could convert to exponential form. And you'll get what? You'll get y, sorry. What you'll get again, 2 to the y is equal to x. When you convert to exponential form, you'll get 2 to the y is equal to x. Remember that? 2 to the y is equal to x. It's like if you have this, log a is equal to 1. You carry up this a, carry across the 1, make it equal to a. So, yeah, so that will be 2 to the y is equal to x. And then we could take logs on both sides. Take ln, I mean. So it will be ln 2y is equal to ln x. Carry down the y, you'll get ln 2 is ln x. You'll get y is equal to ln x over ln 2. Ln 2 is a constant. So when you differentiate now, you'll get dy dx is equal to 1 over x all over ln 2, which is the same as 1 over ln 2 by x. Okay, so yes, you could change the base, or you could convert to exponential form, then take ln on both sides. right? But as you all said, that could also work. You could change the base to ln x over ln 2. Same thing. Same thing you're seeing right here. Question? Question? Tell me now. How I have which part? Here? Oh, because I start to differentiate. The differential of y is dy dx. The differential of ln x is 1 on x. And there's like a constant. So I could have written it like this. 1 on ln 2 ln x. So the differential of ln x is 1 on x. And I multiplied by 1 on ln 2. Sure? Or if you want, you could use quotient rule, but right? But ln 2 is a constant. Right, but as we said, change a base would have been just as easy, probably easier. Right? Change a base would have been much easier. You just skip out all those lines there. I just wanted to show you by the same format. Right? One for the road on this, right? Last one. Right? Let's see what you did. I like the change-based method. So this will be ln x on ln 10. When you differentiate y, you'll get dy dx. Differential of ln x is 1 on x over ln 10, which simplifies to ln x ln 10. Are you okay with that? Sure. Okay, nice. Let's try a past paper now. Any questions online, Jenna? Any questions, Jude? Hello, okay. Okay, again, the trick is to just put it into a form that you're comfortable with, right? Huh? So I just differentiate. What's the differential of ln x? Right? So I write that there. And ln 10 is a constant, so I'll leave it underneath. That's all. Oh, complete. So that is 1 on x divided by ln 10. 1 on x multiplied by am I flip it over? Yeah. All right. This one here, the key is to simplify before you try to differentiate, right? So I want you to show that there for me. Right, the rain start back to fall a little loud in case you're not hearing me, right? But show that, please. Show that, please. Bring me up in front. No more on the room. Forward room. You guys online activity. Activities. Right, I see now what me like keep sending activities. I'm gonna start to this now. All right, let's go. Let's see if you all got it right. So y is equal to ln 1 minus x over 1 plus x all to the half. Right? I'll take the half and bring the half in front, and I'll split up the ln. I'll get 1 minus x minus ln of 1 plus x. Right? And then I can begin to differentiate. So I'll get dy dx is equal to a half by differentiating inside the bracket. So I'll get 1 minus x1, 1 over 1 plus x. Right? Just to make everything look a little simpler inside, I'm going to find the LCM. I'll get 1 minus x squared. I'll get 1 plus x on top minus 1 minus x on top as well. So I'll get a half by 1 plus x, a half by 1 plus x minus 1 plus x all over 1 minus x squared, which will lead us to dy dx is equal to a half by 2x all over 1 minus x squared. And then negative sign missing somewhere. All right, here, -1. All right, sorry there. Right, it was between -1 on top there. The differential of 1 minus x is -1 over 1 plus 1 minus x. And you'll end up with -2 instead. So this 2 will cancel here and you'll get -1 over, or -1 over x squared minus 1. This will cancel, so you'll get 1 over. That's it. Right? I initially left out the 1 here by mistake, right? Sorry about that. Sorry, the minus sign here. Look at that. What mistake you make, William? Huh? All? I watch it there and you're going good. Wait, you differentiate back? Oh, and then differentiate. Yeah, well, I real wrong. Yeah. That real wrong. That's not just wrong, not real wrong. All right, so you try to simplify it out first and then apply the rules. Online, are you okay there? So we shall you okay there, Shivani? Hey, Shivani, quiet today. You know what messaging? Shabara. Are you okay there? All right, well, I don't like how you all did this. I want to give you one more and then I'll give you a break. All right? Just one more. Once William get this, we're good. To make sure William get it. No, William, never stop, William. We will never stop, William. And no more square roots. Hold on, one of the old years have a square root. All right, stop that. All right, we'll stop there. Take a little break, right? I want to show you the inverse trigs first before I give you this next one. Right, so they're going to ask you next for those who don't want a break and they want to go and read up or think about how you're going to differentiate y is equal to cos inverse x. Actually, sine inverse x. How you're going to differentiate. Right, others take a little break. How long? 12 minutes. Take a little 12-minute break. We start back 3:45 and then we go into the differential of inverse trigs. Okay, the last one? Sure. I can bring any board and give you our next one. So make sure you're good. You get my mark. Take your time, copy it down. Sorry, I mean take a break. Right, we will start back with the inverse. But have any ideas or for the inverse? Sine inverse x is not the same as 1 message today or yeah. You know online today? No online. You can do it, yeah. So you got sign to do it. Make a differentiate. Different shape. Okay, differentiate sign to do it, okay, right? Make a differentiate or differentiate sign. So you can do that. So you get sign to that.
What was that? But I think James I know. No, I this. This dog. That one James and James and give me all this. You know it's crazy, but James and you guys are stuck with no, because James and I see this. Hey, we are. People online for the kiss. Oh, let's see. I know it is. Pretty much move over there from here. Okay. What did I see from that? Good. Yes. And then start. Then you have to.
Right, let's go back. So we're going to try to differentiate up. All right, welcome back there, Olia. Let's start back. Through the reach back. Wait, they got people drop over there. The rest of them going. All right, so how are we going to handle, oh, sorry, the heading is differentiating inverse trigs. Differentiating inverse trigs. How are we going to handle something like this? Well, remember, for you to differentiate, all you could use is rules that you actually know, right? You can't do something you don't know, right? So you have to go back to something that you know. We don't know how to differentiate sine inverse x as yet, but we know how to differentiate sine. So what we could do is we could move sine across, sine inverse across, and we'll get sine y is equal to x. So if you recognize, we have x as the subject of the formula, right? So what we could do is we could similarly, the way we would have differentiate y is equal to sine x, we could do that here. We could differentiate x with respect to y, right? And the differential of x with respect to y cos y. Okay, well, what are we trying to get again? We are trying to find dy dx. So right now we have dx dy. So to get dy dx, what you will do? Flip it over, right? Flip it over. So you'll get dy dx is equal to 1 over cos y. Okay, but the problem is we have y in terms of y. So we need to find a way to get rid of cos y, right? We have to replace this. We have to replace in terms of x. All we know about x right now, we know x is sine y. So here we could do. We could say that since cos squared y plus sine squared y is 1, then cos squared y is equal to 1 minus sine squared y, or we could say cos y is equal to the square root of 1 minus sine squared y. That's okay? What we're going to do now to replace sine y, right? We could use x. X is sine y, right? So since x is sine y, we could say cos y is equal to the square root of 1 minus x squared. Okay with that? So now I could comfortably come back here, seeing this, I could take this off and replace it for that. So I could say that dy dx is equal to 1 over the square root of 1 minus x squared. So that's it. The moral of the story is this. Right? The moral of the story is that the differential of sine inverse x is 1 over the square root of 1 minus x squared. That's the moral of the story there, William. Okay? So if you don't remember it, you have to be able to work backwards to that long thing then. Right? Take your time, copy it down. Any questions? Any questions online there? Jaden? Oh wait, no, Jaden, if you remember your differentiation. Jaden, if following a little bit. Yeah, okay. Copy it down, and of course, I'll give you sine to, cos inverse to do. So if you finish, differentiate cos inverse x. Same procedure. Okay, right, the tell you, remember you can look at the videos, right? This is differentiation 1. So all I'm gonna do for the rest of the class is to finish up differentiation of inverse trigs. And then do a combination question in the end. Am I writing? Changing it, right? Well, I'm not changing it, but that's going to ask you to do cos inverse. And if you finish cos inverse, go right ahead and do tan inverse. Right, do tan inverse one time. Hey, what's your quiz about Barbie? Barbie. Sugar or Barbie? The movie, Barbie. So, it's got to dress up. Everybody dress up in pink and going on with Barbie. That's what every sugar. Oh, okay, okay. And my wife trying to get me to go and watch that. Sit down, like flash or something. All right. I'll try. Right here, finish cos inverse and tan inverse. Right. Let's do cos inverse and tan and let's do both of them at cos inverse and sine inverse. Tan inverse, sorry. So this will be cos y is equal to x. X is equal to cos y. Dx dy is equal to minus sine y. Right? We know that sine y is equal to the square root of 1 minus cos squared y. Or sine y is equal to the square root of 1 minus x squared. So when we substitute, we'll get dy dx. Of course, we had to flip it over, right? Dy dx is 1 over the square root of 1 minus x squared. So same thing except for the sign. Right? Same thing except for the sign. Everybody okay with that? Online, any issues there? Shavish, Selena, are you okay there? Varun, are you good to go? Any trouble, let me know, right? You all finished tan inverse already? You all finished tan inverse? Yeah. Oh yeah, do tan inverse first for the finish tan inverse. No. But just be careful, it'll be a different identity. Yes, send it now. Send it if you want. If you finish, take a pic and send it out. Let's check and make sure you do it right. Nice, correct, Shivani. Correct. Shavish, that was you. Yeah, Shavish, good job. Hurry up. Last 2 minutes. I want to see where you all get. I'll tell you we'll on the board. I'm going to show you. All right, let's check out tan inverse. Are we done with that? So this will be x is equal to tan y, and dx dy is equal to sec squared y, and dy dx is 1 on sec squared. Right? And of course, we know that sec squared is equal to 1 plus tan squared. Right? So when we make our substitution, we'll get dy dx is equal to 1 over 1 plus tan squared. Tan is x. So it's 1 plus x squared. Okay, nice. Okay. what would happen if we have a cos inverse 2x or 3x, right? That's where the rule will change slightly. Same thing, same procedure, but you have to include the a and thing as well, right? So I'm going to show you how to handle that. Copy down for those who didn't get it. So the important thing in proving this one is that you know the identity, right? 1 plus tan squared is x squared. So we can kind of tackle the past paper now. All right, so last thing. All right, so the last thing that we just have to generally note. Right, so generally, we need to know that the differential of sine inverse x on a is equal to 1 over the square root of a squared minus x squared. Right? So there's a little a squared in there when you simplify it out. And tan inverse x on the other hand is a over a squared plus x squared. Okay? So those are two versions of the rule I want you to learn as well, right? All right, so good. Let's try to bust up the brain a little bit here. Suppose I ask you to differentiate tan inverse x on, sorry. What do you think it will be? Look back at look back at cos inverse x. Look at the difference between cos inverse and sine inverse. Guess the sign, right? Guess the sign will change. Right? So without doing it the long way, what's number one? Without doing it the long way, what's the answer for number one? Right, look at the formula and you should see that a is 2. So the formula is what? Based on the rule, it'll be 2 over 4 plus x squared. See that? It's important that you understand tan inverse properly, because when we go to integration, they love to ask you to integrate this. Right? They love to ask you to integrate that. So you need to know that tan inverse in particular. Try sine inverse 2x, please. Simplify it as fast as possible. Yeah, 2x good. Yeah, do sine inverse 2x. Try sine inverse 2x. You could use the formula. You all recognize that we could also use chain rule too. If we let u equal to the bracket. If we let u equal to the bracket, we can also use chain. I'll show you on next one, but right. We go through it after the chain. Try this one. Any formula. Try and figure out what A is. And simplify it. Type it down. I want to get it here. X divided by that in here. X divided by but for real. So inferior. Oh, okay. Right, so as I said, you have to simplify. You can't just leave it like that, right? So you'd recognize that this could be written as x over half. So it means that A is a half, right? A is a half. So the form, it will be 1 over the square root of a half squared minus x squared, but you can't leave it like that. So that'll be 1 over the square root of 1 over 4 minus x squared, right? You have to be able to simplify this out, right? You have to be able to simplify it out. So what you could do if you want is to factor out 1/4. So it will be the square root of 1/4 by 1 minus 4x squared, right? The square root of 1/4 is a half. So it will be 1 over half by the square root of 1 minus 4x squared. And you could flip the 2 on top. You can flip the half on top and it becomes 2 over the square root of 1 minus, I can't fit it there, right? I just fit in it here. So it'll be 2 over the square root of, right? So you have to be able to simplify it all the way. So square the half, you'll get a quarter, factor out the quarter, and then square root the quarter and flip it over. Right. As I said, if you wanted, you could have also used chain rule. So I want to show you how you could use chain rule here. Do the long way. Okay, yeah, that could work. That's a long method, right? But that could work. All right, next one. Suppose I gave it something like this instead. Suppose I said for number 3, I said differentiate tan inverse. I'm gonna give you one from here. Tan inverse 2 plus x squared. Right? In a case like this, is not really in the form that you're familiar with. So we could let u equal to 2 plus x squared. And we'll get y is equal to tan inverse u. So it means that we could find dy du. Dy du will be 1 over 1 plus u squared. And therefore, dy dx using chain rule will be dy du multiplied by du dx. We already have dy du. So we could get du dx from here, which is 2x. And then make a substitution. So you'll get 1 over 1 plus u squared by 2x. So your final answer for dy dx is 2x over 1 plus u squared, which is 2 plus x squared all squared. That's the answer. Right, so here, of course, you'll recognize that I use chain rule. Ready? Okay, so those are the differentials that we need to learn. And let's give a little try on some past papers. Let's try some past papers now. right? I want to combine what we did, what we did today, right? Oh, look at it. I found it, I found it, I found it. This is 2012. We're almost done, right? We're almost done. One little question. Then one more and we're done. Did the camera working today? I guess not. Camera isn't working, so I'll have to write it out. This is June 2014, right? Right, 5 marks for it. Differentiate y is ln x squared plus 4 minus x tan inverse x on 2. Do you think that? second part is what? After the minus product, right? Third number, third. Right, let me check out that, and then let's kind of wrap up. No, I do one. I'm tired already, but one more way. Just one more. Right, and on Wednesday we'll wrap it up and we will do implicit differentiation and we have implicit and partial to do. And the question is on implicit and partial. Right, let me see, have any answers here? I've shown. Shiva, you finished yet? Right, remember I told you that this will be u and this will be v. Right, so y is equal to 2x over, sorry. dy dx is 2x over x squared plus 4. You'll have that right. And then we're doing u by v. So it's x by the differential of tan inverse x on 2 is 2 over 4 plus x squared. Right? Minus the differential of x is 1, sorry, plus differential of x is 1, and then you write back tan inverse x on 2. Right? Not much you could do after that, right? So you'll end up with 2x over x squared plus 4 minus 2x over x squared plus 4 minus tan inverse x on 2. What you'll recognize, this will cancel, and you'll get minus tan inverse x on 2. Correct? Anybody else got that? All right, let's see you staying it down there. How about it? Very good. Okay. Anybody else got it? Adam got it. Okay, nice. Just one more and we're done. 2017. All right, last one. Please differentiate. Please differentiate. This is 2017, number 1A. Find the first differential of f of x is equal to cos inverse sine inverse x. Cos inverse sine inverse x. Do you think there? Last one. 3 marks. Only 3 marks there. Only 3 marks. Right, 1 minute again, are we done, right? Let's just correct all this. Let's see what we got now. So du dx is 1 over the square root of 1 minus x squared. Y is equal to cos inverse u. So dy du is minus 1 over the square root of. So now we can make our substitution. Dy dx is equal to dy du by du dx. Right, dy du is 1 over the square root of 1 minus u squared. Du dx is 1 over the square root of 1 minus x squared. Right, if you want, you could bring the two square roots together. So you'll get the square root of 1 minus u squared by 1 minus x squared. But to be honest, we wouldn't really simplify much further than that. So that'll be the square root of 1 minus the square root of 1 minus u. U is sine inverse x all squared multiplied by 1 minus x squared. Right here, minus 1 on top here. It can't really go much further than that. Okay. If you expand, you'll get a small quadratic looking thing at the bottom. You're okay with that?